Okay, so Modeler 10.2, we've got some new big areas of SysML2 that we've implemented. So this is building off previous releases. We're sort of going through the cycle, the logical sequence. And we're near the back end now. So defining behavior with states and then testing the system using analysis, elements, and verification. And analysis cases are where we do the calculations. So we can define mathematical equations that describe how the system will behave. And then we can use verification cases to perform structured testing that uses analysis. We've got the ability to import SysML2 files. So the SysML2 standard, the models can be defined graphically, like you see here in the top images, or using the textual notation that you can see in the middle image. The two models are the same, totally equivalent, but a different way of viewing the definition. Today, everybody who's working with SysML2 is working with this textual notation. So the only models that are really out in the world are in this format. So this gives us the ability to import those textual notation models. Modeler will automatically create a model with all the right SysML2 elements. And then from there on in, Modeler can take ownership of that model definition. So we've got it now in our database. We can manage it from there on using the Modeler features. Into the future, in a future release, we'll provide some capabilities for modifying the textual notation as well. We've got some OSLC capabilities that we'll look at, the advanced populate that we've mentioned, and then some infrastructure work for database management. Okay, so we mentioned SysML2. Here are the different areas. So we now have good coverage in all of these areas, really apart from this API area. It's been a priority in our roadmap for the last few years. So we've got a lot of capabilities now, but we've still got quite a lot to do going forward. State modeling is a type of behavior. So it ensures that you can model the behavior of a system over time. So our system had a vehicle in this example had different operating states, different types of power modes, and we can model when we transition between these different states, what triggers the transition, what the system will do when we move between these states. So we can see some actions here that are things that will occur when we move into those states or move out of those states. And we have the way to specify the logical sequence and the logical flow. This is one way of understanding the behavior of a system, ensuring that the sort of concept designs that we've built work effectively, work as intended, and that the major instructions that a user is going to use will trigger the right behavior in our system, in our product. So here's another example. If you're familiar with SysML2, of course, we can create definitions of states. Part elements can kind of own the behavior of that state by using this exhibit state element. So essentially, this vehicle part owns this type of behavior. We saw these definitions as well. We can see these relationships very clearly in Modeler, and we can navigate from the usage to the definition very easily. We support parallel states. So typically the states will be sequential, but you may also have states that run concurrently, so parallel states in this case. We use drag and drop a lot in Modeler. So when you create some actions, in this case, you can drag them and drop them into the different other elements to specify when they're becoming an action for a state. So nice and modern user experience, good productivity for the modelers. Same again here on the transition. So when we control the sequence, we can specify events that occur that trigger the transition, and we can specify actions that occur during a transition. These are optional. You may not need to model to this level of detail, but we can include these events, conditions, and actions. Here's an example of exhibiting those states that I mentioned again. It's a way of referencing some of the state-based behavior definition. Okay, let's have a quick demonstration. So we can create these elements using the context menu, so the right-click menu from the packages on the left, or we can use the toolbar for the diagrams, as we see in this demonstration. So we create one parent state, then two substates for the different types of power modes that our vehicle is going to have. We can put in flow nodes like start and end called done. And then we can use the the transition to specify the sequence, the flow between these different states. And you see in this example, we can flow back and forth between these two power mode states. So there'll be some kind of trigger within the system that will indicate when we move from purely electric to a hybrid mode. So we can specify the condition and the event in here as well. We're going to give these a name. So it will be dependent on the speed of the vehicle, which mode we actually activate. Do some rearrangement of the diagram so it looks nice and tidy. And then we can go and specify some of the actions that will occur when we go into the hybrid mode. So when we move from the pure electric to hybrid, we're going to be starting up the combustion engine. So we want to specify those actions. We've got a start engine and a stop engine. And then when it's running, we're going to have a monitor action that will keep an eye on our combustion engine as we're in hybrid mode. So important to mention at this point that we do not have the parametric equations, the maths and the physics fully implemented in this version. That's going to come in a future release. We have it for SysML1, but not yet for SysML2. But obviously at this point, we could perform some level of calculation on the system that determines what speed it's at, and then it will transition between these different states. Here we've put a guard and action onto the transition itself. We can use state definitions, and this is kind of like a typing mechanism. So for common definitions, you can put things into a definition and then inherit them. Here we see where we have a part object, which is an architecture item. And we can reference that behavior from our vehicle part. Okay, so that's state modeling. And that builds upon requirements, use case, structural modeling with parts, and action modeling that we've implemented in previous releases. The next phase of capabilities are around analysis and verification. So an analysis case in SysML2 is a kind of behavior that's a step, or really a set of steps, that conducts some kind of analysis. Typically, it's going to be some kind of calculation or simulation, some form of testing. So we identify what is being analyzed. So there'll be a subject, and it'll be, the part of the system that we want to look at. And when we look at this as one part, it's actually a part that has lots of nested parts. They're not shown here, but it's a hybrid SUV. If we expand this out, it has lots of parts nested as subsystems and components. So we can specify an objective. So that's typically a requirement element. So this is how we start to link the existing parts of the model together to our testing. We can specify the objective as well as the subject. And as I mentioned, this could be a calculation or a particular action. It can have input and output parameters. So we can take in attribute properties from other parts of the system and then make changes on the basis of some analysis. A trade-off analysis case is used to model when you have more than one option, more than one solution option for a particular design problem. So from a set of requirements, we may come up with several different design solutions, and we can use trade-off cases to capture and manage those. So we can run some calculations, some analysis activities, some simulation, with the intent of selecting between some alternatives. So we can list the different solutions, we can perform the equations and the analysis, and then come out with a result. Okay, so here we see it in Modeler. Typically, a lot of these elements look very similar. They're typically rounded cornered boxes. Definitions have square corners. And as we see, we can nest items very easily by just creating the symbols inside each other. So we're setting up an analysis for a braking system. We're going to run some simulations. This might be something that's done in another tool, for example. It might be something that's a mathematical equation that we'd run in Modeler, or using some of the integrations we have with things like Simulink or ANSYS Model Center. Then we might do some analysis. So a very simple sort of analysis set of steps here, just to show as an example. Here we can specify the objective. So we can go and choose a requirement. So we need to meet the industry braking regulations. We can bring in the subject of the analysis. So this is our braking system. This may be an existing part, or it may be just a reused part that you're using for the analysis. Here we're going to bring in the results as well. So we'd be able to output an attribute with a calculated result, or some information and some text. And then we can add that to the result of the analysis. So a really quick demo. There's more capabilities than we've seen in the demonstration, but that's just to give a flavor of the creating analysis cases and linking those different types of objects. A verification is really like a test case, and it's used to collect really a formal verification test activity. What we've just seen with those analysis is really just some kind of in-work maths or analysis that you want to do as you're modeling. The verification is a more formal review that you want to do. And of course, at that point, you'll want to make sure that you check satisfying requirements that are relevant, and then provide some kind of verdict in the end, whether you've passed or failed the verification. So again, we can include actions, we can include analysis elements. So in this example, we've specified an objective that's a requirement. We've got our subject, which is the part called braking system. We've got an action that's part of the verification to do some prep work. And then we're going to reference the analysis that we defined a moment ago, where we actually run the simulations. And then we've got another action where we assign some results to another part of the system. On the right-hand side, we can see that it verifies a specific requirement. So this is a key relationship between the test and the requirement. And we can, of course, derive it back to the subject as well. And then, of course, we can use the definition elements as well. So let's quickly take a look. You see the user experience is very similar for a lot of these different types of elements. So that's really good, because once you've learned a bit of SysML, it's easy to learn other areas very easily. It's much more consistent in terms of how it's been designed and architected. So in this demonstration, we just recreate the example that we saw a moment ago. We have a verification to verify the brake system. We'll do some preparation. In fact, I'll jump back a second. So here's an example of using drag and drop. So we're referencing an existing analysis. And what we've done here is created a redefinition of that analysis. So this is a new element, but actually it's just really a copy, a reuse of that analysis. So again, we specify we can use drag and drop to drag a requirement. as the objective. We can create that verify relationship with the same requirement. We can bring in the subject very easily using drag and drop. And we specify it as a parameter. So it's actually an input into this verification. And then we can specify a verdict. This could be done programmatically. In this case, I've just manually gone and set as a pass. So this is not actually part of the systems model. So we start with requirements, then we start with use cases, then we start with functions, and then architecture. So different parts of these are actually part of the design. What we've just seen, the analysis and the verification, it's not the system design, it's the analysis and the testing of that system design. So it's important to distinguish that, because MBSC has a lot of different elements and SysML2 has a lot of elements, and some of the design, some are just supporting or driving the design. Okay, what else have we added in this release? A nice intelligent guidance tool. We had part of this in the last release, but we've expanded it out. So when you do some modeling that's not really compliant, or we think it's incorrect, you get a notification and then some information on what's wrong. So we'll keep building that out as we go forward. Here's our textual notation importer. So I described that a moment ago. Here's an example of textual notation. We can import it into Modeler and it'll automatically create this model. So let's see a demonstration of that. So we start with a really simple model. It's a camera model with a few parts in there in a package. This is one of these examples that's provided with the standard. So we go and select that .sysml file. We can do some analysis, make sure the syntax is correct. We can do a deeper analysis and check all of the references. There can be many embedded references within SysML2. So in this case, it's looking for something else called picture taking. So that has resolved most of those errors. It can now locate the referenced elements. You can see the actual textual notation for the specific elements on the bottom there. When we're ready, we can click import, and as you can see on the left, it starts to create the model. So nice, simple example. Here's the model that's been created, some parts, some actions, no diagram, but with our new feature that we'll see in a second, you can automatically then get all of those elements populated onto a diagram. So this is the feature that I was describing. When we populate today in Modeler, the results aren't always great. Items are sort of thrown on top of each other. So this is a really great enhancement that allows you to add a lot of existing elements onto a diagram in one step, and it will optimize the layout of all of the symbols that get added. It's configurable in a grid. It moves and deals with existing symbols. So when you add new items to an existing diagram, it handles them quite gracefully. We've got a new function to make space. So when you expand a symbol, if you hold down Control, it will move the existing symbols out of the way and place them nicely. So this is a really good way to make space when you're adding new elements inside a symbol. And it works for the main diagrams, for the main profiles. I think UAF as well. UAF isn't listed there, but it works for that as well. Okay, I'm going to jump on to the next demonstration. I've got two movies for this, so I'll just show this one. Again, we start with some textual notation here. So we go through and run the import, just as we did a moment ago. So here's our imported model. But really, we want to be able to see this on a diagram. And the advanced populate allows us to do that nice and easily. So we can drag one of those top level elements, then run the populate. This has been speeded up a little bit. It takes a couple of runs of optimization to get the best results. This is quite a simple diagram, but in very complex diagrams, it takes a little while to complete. That's a balance, though, with saving you a lot of time doing manual modeling. Of course, we're looking at ways to improve the performance. Okay. See how it actually goes through multiple phases of optimization. Okay, so within 20 seconds or so, we've managed to get the main elements onto a new diagram. This would have taken you 10, 15 minutes to do manually, maybe a bit longer, which isn't really acceptable for a user. So this is a big step forward in productivity. And as well as having this auto-populate, we can now populate multiple items. So we see in this example, we've selected 3 symbols and we've done a populate on all of them. Before, it was only 1 item at a time. So this is a fantastic enhancement, a really good usability feature. The next one that we've added as well, this is something quite small, really just a filter on one of our complex user interfaces. When we're choosing the compartments we display on a symbol, this is a big list. So you can now filter it by the type of solution. So if you just want to look at the SysML2 properties, you can select that and a lot of things are filtered out. Here's reverse lookup with CodeBeamer. So this is providing that bi-directional traceability. I think most of us are familiar with these OSLC integrations. In this case, the link has been created on the CodeBeamer side. It's in CodeBeamer's database. The modeler user doesn't have visibility directly, so he can use this find external links capability. So let's have a look at that demonstrated. So we start in CodeBeamer. Here's a requirement, I think it is. We can go and have a look. There's an OSLC link to a model item. It's actually just a text document. It's not really a typical MBSE item. It's just a text document. So if we're in Modeler as the model user, we wouldn't know about that link without this reverse lookup. So we can run find external links. It will contact CodeBeamer. It's found a link, says, okay, there's a requirement that points to this document in Modeler. So it ensures that you have that bi-directional visibility for those links. And this completes the set pretty much. I think all of our sort of engineering digital thread products now have reverse lookup with each other. We replaced our web browser in Modeler. So previous versions of Modeler, we had challenges really rendering complex web pages. But now we've got the ability to display any kind of modern web page. So there's PTC. Here are the previews for CodeBeamer. So we can now see all of the rich content, the images, similarly in Windchill as well. Here's the information page in Windchill with the embedded Creo thumbnail as well. And let's have a little look at this in action. Okay, this is kind of slow. Okay, so here's a view of the CodeBeamer requirement resource via OSLC. And here's a view of the Windchill PLM. And you can interact with these web pages as normal. And from here as well. As well as OSLC, we have a HTML link feature in Modeler. So this is used for creating a web link to any kind of web resource. So this really improves this capability. You might want to link to a web document, a PDF, an ISO standard, a HTML link to a GitHub source code repository, Jira. You can link to obviously third-party products, Onshape documents, Team Center pages. So it's a really flexible way of creating any kind of link. It's a basic link. It's not like an OSLC link with suspecting and status. but it's still a very useful feature. And now we can render those target web pages properly. Okay, database management. We've now got an easier setup when you're using remote SQL. So when you do the install now, you can then type in the machine and the instance of SQL Server. So and then it'll go off and find it as part of the install. So much easier. It's automated through the install. Support for SQL Server 2022. We've improved an issue we had with locking when items have been locked. So we've now got some like a heartbeat capability that will check for any remaining locks that should be closed. So this should help a lot with quite a few customers. I don't think it's common to just Modeler. I think a lot of database products have similar kinds of issues with locks being maintained when they shouldn't. We've optimized we've done some optimization to the reconcile and rebase functions. So these are part of our configuration management when we merge branches back into the trunk. So this has been optimized for performance, and we've cleaned up some data integrity issues as well. We're now in compliance this release with the US executive order. So this is aligned with NIST's secure software development approach. So this is a good step forward, certainly in our target customers of FA&D. Okay, so we've managed to get through roughly on time. We'll have a bit of time for some questions as well, if there are any. But so the main focus, as we've mentioned, is System L2 for this release. Now is really the time companies are going to start selecting their next generation tools. We've got a pretty complete set of System L2 capabilities. You can model requirements, functions, architecture, and testing, and then you can start to build the components for the maths, all of the physics-based simulation. So that'll be coming in a future release. We can import the textual format. So this gives us the opportunity to really take ownership of all of those text models that are out there in the community today. We can just bring them into Modeler very quickly, take ownership of the model from there on in. I think a lot of the people involved are happy working in an IDE, a code editor of some kind, but really, I think a lot more of the users, not the people building the standard, the end users are going to want to use a tool with graphical notation as well as the textual notation. So really that's our goal, is to support graphical and textual. Today, everyone's just been working in textual. So we need to take advantage of that and bring in all of those models. On the integration, we've completed OSLC with our reverse lookup with CodeBeamer. We've got the new web browser, the web components, so we can look at rich web pages as well. And then the diagram creation with the advanced automatic layout features from Advanced Populates. So a good mix of new capabilities that are strategic with System L2, some existing maintenance for things like OSLC, and then some real competitive targeted capabilities around usability. Okay, thanks everyone for the time today.